Hey there, Geometry. It's Mr. Lamb coming to you with Unit 2 test, page 3. Page 3 is out of 7 total points. You will see the first 3 points on the top. Let's talk about those 3 points first. So the question number 11, there are 3 lines. Obviously, it's 1 point each line. So it says name the postulate SSS, SAS, ASA, or AAS, or none. That can be used to show that the 2 triangles are congruent. Remember, in order to have congruence, we need a minimum of one side has to be congruent. Otherwise, I don't know how big they are. So as I look at part A, I see that I have 2 90-degree angles, so those angles are congruent. I see that my angles down in the corner, bottom left and top right, they are marked to be congruent. And these are bow tie triangles, so I also have this angle here in the middle that's going to be congruent. So I have 3 angles that are all congruent, but I don't know a thing about the sides. So because I do not know a side length, that first one is none. You do not know that those 3 things, that those 2 triangles are in fact congruent, because you don't know if they are the same size or not. As I look at the one in the middle, B, they share a common side right there in the middle. So they have a shared side. And then I see that the top is congruent to the bottom, the left is congruent to the right. So this is side, side, side. I don't know anything about the angles, but I do know information about all of the sides. And then for C, I see that angle B is congruent to angle E, that is 1 angle. I see that angle C is congruent to angle F, that is 2 angles. And I do have one side. I have side BC and side EF, so I just need to make sure that it is in the same location. And BC is between my 2 angles, and EF is between my 2 angles. So this is angle, side, angle. If I would have had AB congruent to DE, then it would have been side, angle, angle. Or angle, angle, side, whichever one. Or if I would have had AC congruent to DF, then I would have had angle, angle, side. But because that is an included side, it is in between angle B and angle C, then it is ASA. All right, as I take a look at question number 12, it says isosceles triangle EFG is shown where FH is an angle bisector. And it has a little 5-step proof, and I need to fill in 2 pieces of the proof. You're going to get 2 points for the 2 statements. You're going to get 2 points for the 2 reasons. So this is worth 4 total points. So let's take a look at this proof and see what we're dealing with. I've given information that FG is congruent to EF, and FH bisects an angle. It bisects angle EFG. The second line says that angle GFH, this angle right here, is congruent to angle EFH, this angle right here. I see that these 2 triangles do share a side. They share this side right here, so I should probably say that next. They share that side FH. So as I look down here, this is the line that I want to say, that FH is congruent to FH. And the reason why something is congruent to itself is this property right here called the reflexive property. All right, looking at my picture, I now have a side here, I have an included angle, and I have a side here. So I have side, angle, side. My 4th line is going to be SAS. Side, angle, side. So I have to name the 2 triangles to be congruent. I can see that the line is right there. So triangle GFH is congruent to triangle EFH because of the side, angle, side property. And then finally, to finish this proof out, I do find what I'm set out to prove, that angle E is congruent to angle G. And you'll notice that it says corresponding angle of congruent triangles are congruent. That is CP-CTC, corresponding parts. That's where we were using CP-CTC. So that is the end of page, I think the last video I'll be breaking down page 4.